Hi, Pascal. Welcome to the Future Proof Operations podcast.
Hi, Benjamin. Pleased to be here. Thanks for having me.
Yeah, great to have you. Could you give us a 60 seconds overview of who you are and what you are doing?
Sure. So I work for Accenture, which I guess most of the people listening to us knows well for some reason. In Accenture, I'm part of what we call Industry X, which is Accenture's version of Industry 4.0. It's to keep it simple. And within that, the offer I'm in charge of worldwide is called production and operation, i.e., we support clients to make their production or operations, depending whether they run plants or large assets, more efficient, more produce more quality, more flexible, more and more, and also, last but not least, more sustainable. And we do this across strategy, technology, and operational improvement.
And you named Industry 4.0. Is it still a relevant topic for manufacturing companies?
Oh, very much so. The clients are very mature about it. So there's no more, what is Industry 4.0? They're right in the middle of it. They understand what's the value, what's the value of getting to what we're probably going to talk about, which is this notion of autonomous operation. They understand that this can deliver a second S curve of efficiency, quality, and sustainability. And right now, they are looking for really expert advice on how. Most of them have done pilots. The pilots have confirmed that yes, there is a huge upside to deploy the Industry 4.0 concept and ideas. And now they want to go from pilot to at scale deployment, which requires the right technology, but also the right operating model. And that's the status of the market. So yes, Industry 4.0 is still in full swing. And it's probably going to be another 5 years before we can say that, it's now being completely implemented across industries.
Interesting. I ask because I think the topic Industry 4.0 is already a topic for the last 10 years, but it takes a time to get into the production areas, right?
Yeah, absolutely. And again, to state the obvious, it's always the same thing. There's the phase where we talk a lot about it. There's academic research, all those pilots. But right now we are right in the middle where it gets interesting, where it's getting implemented, where results are being delivered, where companies are being transformed. So we need to. It's not time to lose focus. It's time to stay very much focused and make it work.
Sounds like there is a lot of stuff happening right now, so there's a momentum. I know
Yeah.
that you are researching on the next generation of manufacturing. How will a factory look like 10 years from now, from your opinion?
Okay. So there's two main directions. First, flexibility across all the industries. Supply chains become less and less predictable. Products become more and more complex and personalized. So there's going to be a general trend of making plants a lot more flexible. They will be more modular. So physically, the plants might look very differently because of this requirement for flexibility. What used to be lines will become islands. What used to be fixed lines will become mobile lines. So there will be, plus obviously, more and more automation. So physically, logically, they're going to look, I hope, more and more quiet. And let me explain why. Because this notion of autonomous operations is that the system is smart enough that it can anticipate. So production lines, should become a lot more predictable, smoother. There's still, by the way, autonomous operation doesn't mean lights out. It doesn't mean there's going to be no one around the machines, but there will be much smoother operations. And from an organizational perspective, what we see a lot is the notion of, again, autonomous teams, where today you have people who run the line. They're there. And then you have people who wait to maintain it, people who wait to check quality, people who do the scheduling. All right. And this notion of autonomous teams is there's going to be an integrated team running that line or that plant. We will be in charge of running it, maintaining it, checking quality, and reacting to scheduling events. And they will be supported, and they will be supported by the right tools, which we're going to talk about in a minute. And whenever they need extra help, then they will rely on COEs. So from an organization perspective, what most of our clients are looking at is those much more compact autonomous teams who are completely in charge of operations, supported by real-time tools. And then whenever they have a problem they cannot solve, they will video in a potentially remote COE, where there's going to be the expert of that machine or the expert of that technology, who might be, by the way, in another plant. So plants are going to work much more in a network versus being isolated. And then again, calling the specialist when they cannot solve things autonomously. So physically, the plants are going to look different. They're going to be much more quiet, much more predictable. And from an organization perspective, they will also look very different.
Sounds like a big transformation. And you touched that factories will look different from a physical perspective. Logically, they will be smarter, they will be modular. And you said that there will be new roles and new responsibilities for the worker, for the frontline workforce. And I think we will go into their topics in detail. But you touched autonomous operations already. Could you explain a little bit more what you mean with autonomous operations, and is it already happening right now, or how do we get there?
Yeah. So autonomous operations, let's look at it again with the lens of the worker, because that's the most interesting. If you in any given plant today, and even in the best run plants, if you look at what people are doing, and mostly the engineers, people on the line, they are operating, but the management of the plant, what they do is probably up to 60-70% of their time is spent just complying, making sure that we are producing the right quality, the right specs. So just compliance. Then they spend probably 20% of their time performing. So not only do we produce the right products with more and more constraints, which we have sustainably, safely for our workers, but also we are producing at the maximum capacity of the plant. And then they have 10% of their time where they can really do what humans are best for, which is think forward. How can they improve the plant? I can gain more performance. Autonomous operations is the system is smart enough so that the 70% of the time, which is just complying, keeping things running safely and producing, can be done by the system within normal boundary conditions. Obviously, if big things happen, people will be needed, and that's what people are good for. So massively reduce the 70%, divide by two the 20%, and then free up time for people to do what they're best at, is innovating, thinking of, I have this new product coming in, how can we introduce it faster? How can we make the plant more efficient? That's the notion of autonomous operations. The plant is autonomous, it runs itself, including the autonomous teams who is running it. But the big change is for the people, all the engineers, where the time they will spend not just running around to keep operations running, but innovating, because they have a system which is smart enough to run the plant for them.
Are we right now wasting time, wasting money, wasting productivity in the factories? Because 70%, as you said, can be done autonomous?
I don't think there's waste, because again, those people are very, very skilled. And so, but they're wasting the most precious, which is their time to innovate. Okay. So again, it's not an idea of waste. It's an idea of time being spent just avoiding waste to time being spent innovating new ways of manufacturing, new ways of producing quality, and new ways of of producing the next car or the next whatever we're going to produce.
I find that super interesting, and it sounds like a big game changer. So if we are able to go to autonomous operations, we will be much more productive, and we can
Yeah.
use the 70% which are now free for being innovative, building new stuff, right?
Yeah, and this innovation will be about, again, because I can think and I can look at this machine and understand how the next version should be. And then the next version of that machine will be much smarter. So we will also accelerate the rate of progress. All right. So what I'm saying is, obviously, why do we free up time? It's not that this innovation is going to be about producing more efficiency, more quality, more productivity. So actually, the rate of improvement, because people can spend time not just keeping the status quo, but thinking of the next generation, the rate of improvement of the overall performance of factories will increase up, I think, up to threefold. Versus gaining 1% of overall efficiency per year or 1.5, they will gain 3 or 5 because they will be able to bring in new technologies. They'll dedicate their time to big thinking versus small fixing.
Sounds like a great vision, but how do we get there? So as I understand, we will not be at autonomous operations tomorrow, right? What is the approach to go there?
Oh, that's a really good point, and where we spend lots of time. And here again, it's all about the people and how they use data. If you think of it, if you go again into any given plant, we said about the 70%, the 20%. There's another characteristics, which is the critical know-how, the really important capabilities. You know how you keep the line running? It's not in the MES. It's not in it's in people's head or in some magic Excel and a mix of those things. All right. And it's going to stay there because of the way we use data today is, again, I'm painting it a bit black and white, but for the sake of explaining. Data mostly by people on the line, people who have this incredible know-how to keep those complex machines running. Data still is seen as reporting. Okay, data is being
Mhm.
captured on my line and it's being used by somebody else to report, and then we get to look at it at the end of the shift, and we have the ceremonials, which are very important, but we wait. It's still reporting and after the fact correction. The first thing we need to do is change that paradigm and go to real time. So the
Mhm.
next generation manufacturing operation systems are all, to use a pedantic term, event driven and real time. The data is not going to be used to report. The system will be smart enough to anticipate, back to my remark on quieter factories, because the system will anticipate and simply initially will just understand when to send which data to who to anticipate issues. So the first step is to break the paradigm from data after the fact reporting to data being pushed to me by the system when I need it. There is this trend happening on your factory, happening on your machine. Here is what you're manufacturing. Here is the raw material. Here is the incoming specs. Here is the data you need now to make a smarter decision.
Mhm.
So completely different. Oh, data now helps me on the moment and it helps me do a better work. First step. Second step, because you have this granular interaction with the person, then the system will be able to understand how that person reacts. Okay, and the famous this knowledge will little by little, very naturally become formalized in a conversation between the system, the engineer who's running the system, and the person doing the work. So then you'll be able the next time to not only send data to the person, but also suggestions. Last time you did this,
Mhm.
or last time somebody else in this other factory did this, and then to put a suggestion, and then the person will use the suggestion. You will get more information which the engineers can mine across plants. And then the next time you will be able to say, uh, do this, and when you see that it's accepted, then you can close the loop, and then you reach autonomous operation for that element of the operation. So this progressive, gain the trust of people, change their relationship to data, and get them to share that precious knowledge, which can then be embedded into the system, then we'll eat on the 70%, because this thing is mostly about compliance. So your 70% will shrink, and then we're back to the previous conversation. So that's all. And we are, when we're working with clients, we are looking at the use cases, not only for the benefit, this use case will give us 500K to the bottom line every year in this plan. That's the number one. But also the fact that this use case will get us a notch, on this trajectory of bringing people along towards autonomous operation. So it's all an art to design a roadmap as a succession of use cases that start with very simple and get more complex to get to autonomous operation. It's fascinating, because if you do it
It
right,
really is. It really is. Yeah.
if you do it right, it's very natural. And people are smart, People in the factories, they're super smart. If you give them a tool that allows them to do more of the interesting stuff and more of the boring, repetitive compliance, they're going to love you. So it's a win-win. And once you start that win-win, it's the reward is fantastic.
As I understand it, you say the foundation to start into the direction of autonomous operations is data and real-time communication.
Yeah.
If I talk with my customers or with potential customers, I take a look into the production floor, into the shop floor, I see that we are very often in that reporting phase, which you talked about. So we
Mhm.
pull data when we need it. Hopefully we have data. Sometimes we even don't have that data because it's somewhere lying around on paper and so on. My question is, how far are we away to go into that real-time communication world? And which kind of technologies do we need to go there?
Really good question. And that's where the notion of digital twin, which is I use very carefully because there's lots of different understanding of digital twin. That's where the notion of digital twin comes in. What is a digital twin? Very simple. And as everything else, it becomes possible because of new technology, but we're going to talk about it in a moment. Today, uh, the data, not only the data is not real time, but data is dispersed. If an engineer is asking himself, well, I really wonder whether the quality of the raw material is creating this problem I have down at the end of the line. The incoming inspections are in one system somewhere. The raw material specs are in SAP. The result, all the intermediate results he needs are in the MES. The final inspection is potentially in a different system. So first thing we need to do before going to real time is all this data, which is disparate, need to be
Mm-hmm.
brought into the same environment and what we call contextualized. That we know
Mm-hmm.
that this was done at that time with this raw material and it's linked to this machine, and all this complexity is best represented by what is called a graph. It's all about relationship. This machine was doing this, and by the way, it was maintained by Mr. So and so at that date, and those were the results. And it's a hugely complex set of relationships, which was not naturally captured by an MES and a relational database. So a digital twin is just that. It is leveraging the power of the cloud and this new notion of graph to bring all this very disparate information an engineer needs to make the right decisions together in a way an engineer can understand. It's really interesting when we implement a digital twin, all of a sudden the engineers say, oh my God, I didn't know I could have all this information pre-masticated, if I may say, where a question that I would need 3 weeks before by getting extract in an Excel spreadsheet and whatever, I can get in 5 minutes. So that's the first one. Then the next thing is IoT. This incredible capability we have to connect modern machines are all spitting out tons of data. Once you have this complex graph and then you can feed real-time data through it, then what becomes magic is any event in your plant can be potentially evaluated like an engineer does. When an engineer, an event bubbles up in a plant, he has all these relationships in his head. He say, "Oh, this is happens, but we're producing this, and we didn't maintain that machine for a long, long time, so it probably is this." Okay, all this again knowledge can now be captured and automated. When an event happens, real time, the digital twin has all those relationships, and you can use AI and machine learning to this is the event, and then what if and what if and what if, and little by little again get back to formalizing the tribal knowledge. So the digital twin is the there's been lots of hype around digital twin. People
Hmm.
are saying now people link digital twin and metaverse. I say, hold on, wait a minute, before we dream about metaverse. No, the digital twin first is a brand new way, very powerful way of formalizing this complex knowledge which allows you to run your plans, formalize it, use AI to mine that knowledge, and then again, so you have two curves. You have the curves we described of bringing the people along, and you have the other curve which is that goes in parallel, where this digital twin becomes smarter and smarter because it becomes more and more complete in terms of describing your operations, and then you can embed some intelligence and some machine learning routine in that. And this is a fascinating science. And this is exactly what we are co-innovating with large partners like Microsoft, leading clients, is how to use those digital twins to do exactly, the curve I just talked to
Hmm.
you about. And
Yeah, you
what
call
I
that
find
the.
what I find fascinating is that it's at the intersection of human science, how do you bring people along, and the best of technology, and it's really again fascinating.
I see that it's fascinating. It's super cool to listen and see how passionate you are about that topic. You talk about the digital twin journey in the direction of autonomous operations. So, as I understand it, the digital twin is a core element to go to autonomous operations. So, we need the digital twin to achieve that level.
I would believe so. And very good point, you bring the journey. Uh, it could seem intimidating to say what I need to model my entire operations, and modeling entire operations is a huge task indeed. The good news is you can start very small. So another
Mhm.
characteristic of digital twins, people remember the experience of rolling out an ERP, where the first thing before you roll out an ERP, you have to freeze your data model, and then you live with your data model forever, which is not a bad thing because an ERP needed that, right? Then they have the souvenir of some initiative which were done around master data management, where again we had to define and there was a big investment because before we could harvest the value of this master data model, of the value of this ERP. The digital twin is completely different. Because of the flexibility of the technology, you can start very small. You can start with creating a with 20 20, 50 different variables and elements and whatever. You can start with the twin of a machine, and you're going to use this mini twin to optimize the reliability of your machine, because reliability is self-contained. Then you will want to tackle quality. So you will bring some other elements. You will bring some QA elements. You will bring a second machine because quality goes across those two machines. So the great thing about digital twin, which is again what we are learning to do with our clients as we speak, is it can be built progressively, one use case at a time. But the big difference is that every use case, when you do today use cases the traditional way, every use case creates a new data silo. Okay, I solved that maintenance problem, but now I have a mini
Mhm.
maintenance data model. And I solved this quality problem, and I have this mini data model for quality. The twin, every time you bring everything together, again, leveraging the power of those graph data, not databases, but graph anyway. All right. So the what's really important is, and important message for the clients who are listening to us is, the digital twin lends itself to progressively building this model, enriching the scope, one machine, one line, I add my flows, and increasing the depths, the intelligence of the twin, where initially the twin will just provide, as we say, hints, then it will provide recommendation, and then you'll be able to embed ML logic into the twin so that it can get you to autonomous operation and potentially run the more repetitive part of your plan.
Yeah, this explanation is a great segue, because it would be my next question: how to start? If I think about digital twins, like you said, it sounds abstract here and there, it sounds complicated. And if I, for example, think of a manufacturer, 5,000 employees, they have a ERP system in use, they have a MES, and now they say, I would like to go into the direction of autonomous operations. I will start to build my digital twin. What is the first steps? You talked about contextualizing data, building, connecting knowledge and data. How can that happen? Do I need to build or buy a new system?
So first, all this technology is cloud-based. So all the tools are available from all the large vendors as software as a service. So the setup time is actually pretty quick. And I'll comment on that later. So the technology investment is very reasonable and very progressive as well. The right way to start, as we said, is one use case. So we believe so much in that we have a program in partnership with a large cloud provider, where we go help clients get their journey started with what we call an MVP. Because probably clients who are listening to us say, yeah, too good to be true. And I agree, too good to be true. So what we do is in 12 to 16 weeks, we come to that client, we look at their operations. So we send people, we know their operations, we know their industry really well. We look at most of these clients will already have, identify tough nut to crack. There's this problem I never managed to solve, and we keep, it stays tribal knowledge. We never managed to automate that thing. So can you help us? So we qualify it. And in 12 to 16 weeks, we come in, we connect the machine, because often that machine will not be connected. We connect the other systems where the data is. We set up the twin because it's cloud-based. We develop the use case. We prove the value of the use case. And this use case is ready to be deployed in other plants. Okay. And that's my best answer is, how do you start? We help you start. We come, deliver this first thing. And it's really amazing. We did this at a large food and beverage company, and it was 16 weeks this time. In the 16 weeks where we solved the first problem, the engineers looked at what we were doing, saw the flexibility of this digital twin, and before we left, they had identified 8 other use cases where they say, now we understand, we want to solve those as well. Okay, so it's also another message, back to my message, that the twin is not an abstract tool for data scientists. It is a tool for engineers. It stores data the way engineers like it, which is, again, relationships. This machine does that, it was maintained, what I said earlier. So that's the best way to start. Very pragmatically, try it. Try it.
And as a manufacturer, I will keep my existing system.
Yes, absolutely.
I will continue to go with my ERP. I will continue to go with my MES.
Absolutely. Thanks for asking the question. Yes. Initially, the twin is completely side by side. It is a decision support system. Your production will keep running with your MES. We obviously do not touch the MES. It is well running. It is certified. It is producing cars, yogurts, or whatever. We don't touch it. The twin is side by side. Then the art is progressively, go from no integration or integration by humans. Okay, the twin will suggest something to the operator, and the operator will turn the knobs. to little by little, very, very progressively. It's probably going to take 3 to 5 years, and it's okay. Progressively integrate the two more and more. And the end
Mhm.
game, you will still have your MES. Your MES is I call it the transmission belt between the ERP and the machine and the shop floor to get things produced. But then the twin will be more and more able to, look over the shoulder of the MES and send back the right settings so that the MES constantly optimize the production. And this progressive evolution of the architectures is another big work we do with our clients across industries, lots of projects, very, very interesting. I wish I had more architects because this is a new science. I wish I had more architects who can understand manufacturing to do this. But CIOs come to us and say, "Okay, I understand this notion of twin. We've tried it now. Now come and explain to me how over the next 3 years I will combine, my existing MOM landscape and this new thing into a seamless architecture that will be the manufacturing architecture that will take me the next 10 years."
You said the digital twin will be for everyone. Let's make it concrete and go down into the shop floor, into the production area, and we have some shop floor workers, some frontline workers conducting a maintenance in the machine park. How will they benefit within that use case? So will they have a smart glass? Will they have a tablet and then have the 3D model of the digital twin? How will that look like?
That's a good point. So first, um, back to everything we say, the benefit will be for the worker. What we said earlier is I'm being pushed at the right time, the right data to anticipate. Okay, it's not that visible, but that's important. So we're gonna move from a paradigm from, all no more big screens. Well, there's still gonna be big screens to please management, but I don't have to go look at something. It will be on my phone. My phone will vibrate. So we go to
Mhm.
mobile. I have a client who tells me, actually, we should not have a control room. Why do you want to have a control room? The control room
Mhm.
should be virtual. We don't need a control room if the system is smart enough to send at the right time to the right person the right data to anticipate. I think it's an interesting. So they're pushing the thinking, but that's the idea. So to the operator, the paradigm will be complete. That will be the biggest change. Okay. I constantly this friendly advice comes to me and allows me to anticipate, allows me to not spend too much time on the mundane stuff, but really focus and nudge me to innovate. Yes, and then indeed there will be the other more spectacular part is when indeed, it was not enough and I have to go repair the machine. Yes, indeed, we will be able to have the people from the COE, you know, the machine will have in model and the people of the COE
Mhm.
will be able to zoom in, and we already do this, but it's still not deployed because it requires some fairly significant investment. But the people of the COE can or automatically, where you will have an overlay of the machine and then you will have guided instructions how to change that part or how to restart the machine or how to fix that micro stops. Yes, that's part of it. But I think that's the icing on the cake. The real fundamental difference is, again, go from after the fact to proactive. Here is what you need. Here is the data you need to make a decision. Then here is what we suggest you should be doing. You don't have to worry about it anymore because the machine takes care of it, and you can think about more productive things, more important things, more
Sound,
innovative things.
Sounds like a promising future for manufacturing companies and for the people working on the shop floor. Which kind of roadblocks or risk do you see that autonomous operations will not happen in future?
Well, I'm going to be consistent with what I say. The problem is not technology. Technology is there. It's getting more and more flexible. It's pretty
Mhm.
incredible, by the way. The risk is if we fail to take people along. If you fail to explain to people, and not just explain, but
Mm.
in the way we deploy, prove to them that this is about enriching their work, not taking their work away. Okay. Obviously, there will still be automation, but anyway, automation is required because the precision and the variety of the things we manufacture, we will need more automation, and then there's a good reason to automate some tasks. So there will be some automation, but the main people we need to convince are, again, the engineers. The people who are going to make autonomous operation happen are going to be the engineers, the production engineer, the quality engineers, the maintenance engineers. And we need, and I spend a lot of time with them to explain how indeed this will, again,
Mm.
70%, 20%, 10%. We want you to do more innovation, and this thing will allow you to get rid of the 70%. That's, for me, that's the key population. If we manage to convince them. Now, the good news is that most product engineers, I got the same color hair I have, and they're going to retire in not so many, they are retiring. And actually, I vividly remember a conversation with a client, the manufacturing CIO of, again, this another large CPG company, when we were having a conversation about Industry 4.0, and the first thing he said is, the people who know how to run our plants are retiring. They are not going to be replaced, and this is a huge problem. So the fact is that ask any of your any industrial, they will tell you they have the hard time recruiting production engineers. And those young
Mm.
engineers, they will not spend 15 years of their life learning the plant, building this intuitive knowledge to run the plant. So they will actually welcome, they will be interested, there will be the challenge for them of building this complex digital twin to run the operation is the kind of stuff they want to do. All right. So I'm positive because there's this big shift in the workforce where a new generation is coming who will actually embrace that new way of running operations versus the traditional way.
So you are positive. Let's think of a CIO, a COO, and I have 1,000 employees. I have a ERP system in place. All my operations on the shop floor are complete paper-based. I want to go in the direction of autonomous operations. I'm positive. I'm a positive thinker. Which topic should I put on my agenda today?
So for the CIO, clearly it is anticipating the evolution of your architecture. Architecture seems intimidating, okay, but you have an architecture for a large company,
Mm-hmm.
but you also have, so anticipating how I'm going to evolve. I'm still going to have an MES. But I need to understand how, besides this MES, I have a flurry of other things. I have Excel spreadsheets. I have, actually, that's the reality. Even in small companies, the MES does the more repetitive task, but there's still lots of very interesting know-how lying in Excel spreadsheets, in paper. All right. So just anticipate how you will be able to make this available. And by the way, when we say digital twin, it smacks of large companies who have to make an investment. But today there are companies who deliver package solutions which don't say digital twin, but bring kind of the same behavior that can be implemented very easily, and
Mm.
the names. So there's a range. There's digital package solutions for small companies, and for the large companies who are very diverse, who need much more flexibility, then they will go to the real big digital twin by the Microsoft and the AWS and all those people. But there are package solutions. So number one, anticipate how you will evolve your MUM architecture to very, very gradually, no nonsense, take all this content which is in those Excel spreadsheets, bring it in a way which is more formalized.
Mm.
And this is called, quote, a digital twin, or whatever you want to call it. For
So start with a digital twin. this is the message.
You should anticipate how you will evolve your MOM architecture so that you can, better use data, and you call it digital twin or not, but that's the idea.
Thanks a lot for being on the podcast, and looking forward to have you in the podcast in the next year, for example, and take a look on the state of autonomous operations again.
Okay, sure, with pleasure. And again, I try not to share a vision, but to share experience of doing it. I think again, what's interesting is it's not a vision anymore. We are learning how to do it with clients, co-innovating with clients, and that's why I'm trying to share, because that's what's most precious for the listeners, to understand how it's done practically versus, again, anybody's vision.
Thank you, Pascal.
So thank you for having me. It's a pleasure, and looking forward to the next time maybe.
Bye.
Bye.